welcome back and assalamu alaikum boys and girls. Today we are going to solve the question 2 of the same paper we discussed already, and we solved question 1. So this is October November 2022 9701/22. Hopefully you enjoyed the previous video and successfully solved the question 1. So I'm going to solve question number 2 for you. So going straight forward to question number 2. Okay, so here is the question number 2. He says, now very simple question, very easy question, but depends how much knowledge you have related to the bonding structure. Okay, so then you can very easily solve the question. He says that the chlorides of some of the period 3 elements are shown in table 2.1. So we see sodium chloride, aluminium, silicon chloride, or even we can say silicon 4 chloride, phosphorus pentachloride or phosphorus 5 chloride, phosphorus trichloride or phosphorus 3 chloride, and sulfur 2 chloride or sulfur dichloride. Both are correct. Okay, so now before answering this question, first of all study this and focus on the demands, okay, and try to answer as I already mentioned. And you, if you are regular on my channel, you can notice that I advised do as directed. Whatever is directed, please do that. Don't do or don't add anything by yourself. Do as directed. It will not only save your time but also impress, or your impression will be more stronger. Okay, so now identify the bonding shown by each chloride under standard conditions, and he clearly advised that use C for covalent, I for ionic, M for metallic. So I'm going to fill this first row. As we know, sodium is a metal, chlorine is a non-metal, so typically the bonding will be ionic, so I'm going to write I. For aluminium chloride, we clearly know it is aluminium is metal, chlorine is non-metal, so the bond will be ionic, but due to the less difference in electronegativity of aluminium and chlorine, it is covalent. And if you accidentally write ionic, there may be chance that examiner accept, but remember, due to the difference in electronegativity, this is covalent. Silicon is a typical non-metal, so chlorine is also, so that's why it is covalent. Phosphorus is also, phosphorus pentachloride or phosphorus 5 chloride is also covalent. Next, so before filling this row, we are going to follow the instructions and read the instructions. What are? Identify in this structure, or in this situation, examiner is advising us that identify the structure shown by each chloride under standard conditions and use G for giant, S for simple. So all the covalent molecules we can see are simple, and the ionic compounds are always giant. Okay, so we are going to see write G for sodium chloride. For all of these covalent, we have to write S for simple. Okay, only graphite and diamond or structure like graphite and diamond are giant, not all. Then oxidation state. Oxidation state is the involvement of electrons by any atom in the specific compound. So in this compound, sodium is involving only one electron. But sorry, I have to read the instructions, otherwise there might be a chance I do it incorrectly. So the advice of the examiner is deduce the oxidation state of period 3 element in each chloride. So yes, we are right and we are doing the same. So sodium chloride, in this sodium is involving its one electron, so you can either write +1 or only 1. Then aluminium is involving 3 of its electrons, so we can say +3. Silicon is involving 4, so it will be +4. In this compound, phosphorus is involving 5 electrons, so it is +5. And in phosphorus 3 chloride, phosphorus is involving 3 of its electrons, so its oxidation state will be 3. and in this compound sulfur is involving 2 of its electron, so its oxidation state stays +2, and you successfully score 4 marks in this question. Next part, write equations for the reaction of sodium chloride. We clearly know it is ionic compound. Okay, the phosphorus penta or phosphorus 5 chloride is a covalent with water. So remember, whenever we are going to add any ionic compound into the water, it will dissolve. So whenever something dissolve, what and how I'm going to say, if you just write H2O, and as it is going to dissolve, even if you write AQ, mean aqueous, we are just dissolving it. So as a result, this will give us sodium ions aqueous. Ions will be splitted into positive and negative charges, and chloride negative ions aqueous. So in this case, there will be no difficulty in balancing the equation, and you will not be, and you may not confused. And otherwise, you may write instead of aqueous H2O. Okay, but that case may or might confuse you that the equation will not be balanced then. And remember, dissolving, no need to balance. Okay, so if you write with water, it's also fine. Like I'm going to write it over here. If you write NaCl plus H2O, this will give you Na plus aqueous plus Cl negative aqueous. So now in this case, as I clearly mentioned, you may confuse that where water gone. Okay, so you either write the equation in this format or this format, both are correct. Then PCl5. Okay, remember the covalent chlorides always hydrolyzed whenever they added into the water. So that's why now we need water, because water here acting as a reactant and it will react. As a result, we will get phosphorus oxide, and which will immediately dissolve to give us phosphoric acid H3PO4, plus we will get Cl, and it will immediately converted into hydrochloric acid. So the final product we obtain will be phosphoric acid and hydrochloric acid, and the solution becomes highly acidic. Okay, to balance it out, how many chlorine we have? 5. So I'm going to take 5 over here, and so you can see 5 hydrogen plus 3 hydrogens, so we have 8 hydrogens. So I'm going to take 4 over here, and now in this case, how many oxygen we have? 4. So almost equation is balanced. Okay, hopefully you understand. Proceeding the next part, which is C, and here he says that in the gas phase, aluminum trichloride exists at equilibrium with dialuminium hexachloride. So this is actually the dimer of the aluminum chloride. You can see the equation, and remember the reaction is exothermic in the forward direction. Then he says complete the dot and cross diagram to show the bonding in dialuminium hexachloride, or dimer of the aluminum chloride. You notice that how many aluminum we have? 2, and how many aluminum we have here? 6. So it clearly shows that each aluminum is involved in making 4 bonds. So to show this situation, you have to follow the tetrahedral arrangement, mean you have to draw one of the chlorine over here and another chlorine over here. Okay, that is the only way in that will give you the tetrahedral arrangement. And now don't need to fill the electrons. The aluminum will also share both of the electron with both of these chlorines, and then you have to take 2 more chlorine to make it total of the 6 chlorine atoms. Now you can see how many total chlorine atoms we have? 4. So this is chlorine, this one, and this one. Plus, as we know, first of all, I'm going to start from the right hand side, and I'm going to show the dot and cross diagrams, dot and cross arrangement. Okay, so you have to show the dot and cross arrangement, like it's little difficult. So here I'm taking help from some other like paint so that I can easily draw and show you. Okay, how this is aluminium, and as I said, show tetrahedral arrangements like this, and another aluminium, and two of the chlorine atoms here like this exactly. So now it is Al. All these are chlorine. These were already provided by the examiner, and we have to show all of the unbonding pair, non-bonding pair, lone pairs clearly. Okay, like this. And now starting from this, as I said, start from the right hand side. This was previously provided. Okay, so now I'm starting and writing in different colors so that you can easily understand what we did. This is chlorine, 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 and chlorine. First, start from the right hand side. This one will show aluminium will participate by its one electron with this chlorine, so chlorine will also with one. How many electron left over which remains unbonded and are called as lone pairs? So 3. Same is the case with this one. And also with this one. Okay, like considering this is the aluminium chloride, that one. So dot and cross, and here one pair, second pair, and the third pair. So now as I show two crosses from the chlorine, so mean this is the dative covalent bond formed with this chlorine, this aluminium atom. Same is the case with here. Here it is dot cross, but two of the crosses remains here, indicating that aluminium is making what? Dot and cross diagram for this one. Hopefully you understand. So you have to draw this structure in your exam. As I can't and I'm unable to draw properly here, when I try to draw it will select it, so making me difficult to draw the electrons, so I showed the bonding electrons here. Okay, so you have to properly understand how I showed. Now proceeding with the next part. In this next part it says that state the effect on increase of an increase in temperature on the equilibrium mixture in equation 1. The equation 1 was exothermic in the forward direction, and we know that whenever we increase the temperature, endothermic reaction is favored, which is the backward reaction. So follow the pattern. First of all you have to say state the effect. So what it is? Equilibrium shifted to the backward side or to the reactant side. So we can say equilibrium 1, equilibrium shifted to backward, or even you can say reactants, towards the reactants. Why? Now you have to explain why. As high temperature favors endothermic reaction, which is the backward reaction, which is the backward reaction. Hopefully you understand. This is the Le-Chatelier principle. Okay, so moving towards the next part, here it says that a 3.30 gram sample of period 3 chloride is heated to 500 K. Temperature is already in Kelvin, no need to change it. If we are using, yes, we are using the general gas equation. So in the flask, then at this temperature the chloride is a gas of volume 250. So volume is given, pressure, but we have to convert it into meter cube, as the SI unit for the volume is meter cube. So how, if the volume is in centimeter cube, now we are going to straightforward multiply this value by 10 raised to the power minus 6, then it will easily convert it into the meter cube. Then what extra we have 323 kilopascal, but we have to take the pressure in pascals, so it should be 323 times 10 raised to the power 3 pascal. So conversion is done already. Now you have to use this formula, PV equals to nRT. Mass is already given, so here I'm going to put the value of n. Remember, n should be or could be calculated by taking the mass and dividing it by mr. Okay, so now if I replace this value here, what I got, PV equals to mRT divided by mr, and as we are only advised to find the mr, so I'm going to remove the mr to one side, and then what I have, we will have mass RT divided by PV. Now just we have to replace the values. Okay, so what is the value of mass? It is 3.30 times R is the gas constant, which is 8.31, multiply by T, which is temperature, and it should be in Kelvin, so it is 500. No need to convert, it's already in Kelvin. The pressure value is 323 times 10 raised to the power 3, multiply by the value of V, which is 250, and as we convert it into the dm cube, then it should be 10 raised to the power minus 6. Now you have to calculate this, and I'm going to use my own calculator to find out the exact value. Okay, so now I'm putting the value 3.30 multiply by 8.31 multiply by 500 divided by 323 times 10 raised to the power 3, then multiply by 250 times 10 raised to the power minus 6. Okay, so what should be the answer? What I got is 169. You have to calculate by your own. Okay, so what I got, it is 169.80. so we can approximate, take it as 170. Okay, now then he says that we have to deduce its formula. So period 3 formula, so we notice that how many elements are there in period 3? Sodium, next one is magnesium, aluminum, silicon, sulfur, phosphorus. Okay, and chlorine we are not going to take it. So now if we take sodium chloride, so the mass will be very less, under 100. If we take magnesium, it will be again under 100. Aluminum somehow goes little above 100, so I have a doubt with silicon, so I'm going to try it with silicon. So if I take silicon, then the formula should be SiCl4. So how many silicon atom we have? 1 time atomic mass of silicon is 28. Atomic mass of silicon is 28 plus 4 times the atomic mass of chlorine is 35.5. Let me calculate this. If it is exactly the 170, then the chloride or the period 3 element should be silicon 4 chloride. Otherwise we have to try with sulfur, okay, or with phosphorus. So the order is just disturbed, so first is phosphorus, then sulfur. Anyhow, I'm calculating this one. 28 plus 4 times 35.5. Wait a minute. Okay, yes, so it's exactly 170. It's exactly, so we can say it is silicon 4 chloride. This is the formula of the period 3 chloride. Proceeding, then he says that an excess of chloride ions aqueous. So remember, chloride ion we can't take simple. It could be sodium chloride, magnesium chloride, potassium chloride, any of the chloride. Okay, so we have to take this as chloride ion aqueous form. So what we are going to say, it is going to be added in 1 cm cube of the bromine aqueous. Okay, remember, when bromine is aqueous, so we can take it as orange. It is orange solution. But remember, as we are going down the halogens group from top to bottom, their oxidizing power is decreasing. Their oxidizing ability is what? Decreasing. So whatever what happened then, if we are going to take aqueous solution of bromine and then we are going to add excess of the chloride ion, what happened? It will not going, the bromine is not going to displace chloride ions into chlorine. So we can say no change takes place, no visible change takes place. And what could be the possibility, the explanation? As bromine is or the oxidizing power of bromine is less than chloride, okay, or chlorine. As oxidizing power or ability of bromine is lesser or is less than, okay, so it could be the possibility and explanation. Next, sulfur dichloride has MR of 103.1 and is a liquid at room temperature. So whenever we have low melting point and boiling points, what it indicates that the given compound is covalent or a simple covalent. Okay, then sulfur dibromide has MR of 191.1, 191.9 and is a gas at room temperature. Okay, the melting point increased, boiling point increased, but it's as we saw can easily understand, the molecular masses are increasing. The molecular masses are increasing. Then what we have to say in this situation, that the type of the intermolecular forces what are depending upon the molecular masses, depending upon the molecular masses. Sulfur dichloride, sulfur dibromide, so is a gas at room temperature. So it is liquid, melting point is higher, and we can say its boiling point is lower. So explain the difference in the physical state of sulfur dichloride and sulfur dibromide. What we are going to say, that the permanent dipole forces, if you can say that chlorine is more electronegative, or the size of the chlorine and bromine is more than sulfur, so either we can say the permanent dipole, or even we can say instantaneous dipole forces of attraction, they are getting much stronger. Okay, so they are stronger in sulfur dichloride, whereas they are weaker in sulfur dibromide. Okay, that is why it is gas at room temperature. So keeping this information in your mind, you can say that the intermolecular forces, and if you specify it's more clear, then more you will get second mark as well. So you have to mention that the temporary induced dipole forces of attractions are much stronger in SCl2 than SBr2. That's it. Okay, next, bismuth is a dense metal in the same group as phosphorus. Draw a label diagram to show the bonding in bismuth metal. So metallic bonding we have to show. For this purpose you may use these circles to show the atom of the metal, at least 3. Okay, and like here In the second row you may show 4, it's fine, otherwise 3 are fine as well. So at least 3 columns and 3 rows. Now inside the circles you have to show the plus sign, which indicates what? The nuclei, okay, or the ionic. So that we can say this one and this one, these are the metal ions, and then you have to show the electrons with this simple dot, okay, simple this. So now you have to label these as well, like this and this. These are delocalized electrons, so hopefully when you write all these, just making this structure and labeling this, you can easily get 2 of the marks. Next he says that bismuth react with chlorine to form bismuth trichloride. Bismuth trichloride is solid at room temperature. It melts when heated gently. So as its melting point is low, because gentle heat melts it, so mean its low melting point indicates that it could be simple, and simple structures exist in the form of a covalent bonds. Then bismuth trichloride react vigorously with water. As I clearly mentioned, I think in above parts, that whenever any chloride is reacting with water, then it must be covalent, as covalent chloride is hydrolyzed. But if it was metallic, being bismuth is metallic, and it was ionic, then its melting point should be higher. Secondly, it just have to dissolve, not to react. Okay, so keeping these two information, the question says that suggest the type of the bonding. So as low melting point, VKN is also hydrolyzed, so only covalent chlorides are hydrolyzed. So we can say bonding suggests the type of bonding. It is simple covalent. It is simple covalent, or the bonding is simple covalent. Then explain answer. As its melting point is low and hydrolyzed in adding water, hydrolyzed by adding water. So these are the evidence that confirm it is a simple covalent molecule. Hopefully the question was lengthier than the previous one, total of 21 marks. Some of the parts were discussed from the physical chemistry and some from the inorganic as well. So please, you have to focus properly and try to solve this question by yourself. And if you found anything fishy and anything suspicious you want to discuss with me, please don't hesitate. Okay, so hopefully you learned a lot, and I will try to post the next question in my next video. Stay tuned, stay connected. We'll see you in the next video. Take care. Allah Hafiz.